Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Fabric 1.21. And in this tutorial we're going to get started with block entities. So first of all, we're going to quickly explain what a block entity is. So a block entity is effectively a block, but it allows you to store data. This data may be anything from just a simple integer or a string to anything such as items, possibly a cable network you may store energy, you may store fluids, anything you want really, you can have inside of a block entity. Additionally, block entities can tick, so you can have a ticking block entity, and this means that you can do something every tick that it's running. Think, for example, a furnace may process its inputs every tick, and it will up the fuel time, up the burn time, and that will all be handled every single tick. With block entities, you can also have a block entity renderer, and this allows you to render something on your block entity. Think, for example, the enchantment table has the book above it, and that is rendered separately as a separate model inside the block entity renderer. And you could also, for example, render a fluid. If you had like fluid tank, for example, you may want to render how much fluid and the specific fluid that is in that tank, and you would need to use a block entity for that. You may also want to render what item is inside of your storage or anything like that. You would need a block entity and therefore a block entity renderer for that. Now, we're not going to be getting that complex in this tutorial. We are going to have a whole sort of mini series on block entities, and this is just the first one to show you how to set up a block entity. So let's go ahead and get started. I've already created a block here, just a very basic block, nothing special, and I've also done the data gen for that, and I've also added the texture in as well. So I'm not going to go through that because that's just normal stuff, that's nothing special, but we are going to want to go ahead and change this so that it is no longer a block. So in this tutorial, we are going to be doing block entities, but I'm also going to be showing you how to create a custom block class as well, because that's basically going to be a very similar process. So I'm just going to rename this block, and I'm going to call it something else. So I'm going to call this example BE block, since that's basically what I've called the block here, so that's what I'm going to call the class as well. And it's generally recommended that you have this end with block, since this is a block class, so we just want to state that it's a block. And then we're also going to change this new block here to new example BE block, and once you change both of those, we can now use a custom class for this block instead of just requiring it to be a normal block. So we can now create a new package inside of our main package, and I'm going to call this block. And inside of here, I'm going to create this new class. And we can go ahead and now import that inside of our block init. And we can actually close this. This will still have an error because we don't have a constructor, but we'll create that in a second. So we can close that now. And all this class needs to do is this class needs to extend block. And then we just need to add our super constructor. So effectively, this is now a custom block. So we can now do anything we want with this block. Maybe we want to do something when you right click it. Maybe you want to do something when it's destroyed. Maybe you want to do something when it's placed. Maybe you want to have specific rules for where it can be placed. You can do all of that inside of this block class. And if you just press Control Space and you scroll down a bit past all the classes, you will see all of these methods that you can potentially override and do whatever you want with. Now, obviously, needless to say, I'm not going to be going through all of these methods, and we are just going to be using one method in this tutorial specifically. And that is going to be the most common one that most people are going to want to use, and that is going to be onUse. So this method is called when you go ahead and right click the block. Now, it is important to note it's only when you right click it with an empty hand. When you right click with an item, you would use onUse with item. But we're not going to be using that one since we just want to be able to do this with an empty hand. So before we continue, let's go ahead and quickly explain what the goal of this tutorial is. What are we actually going to create? So the idea is very simple. We're going to have a block that has a counter inside of it. So it's just going to hold an integer, which will be the number of times that you click that block. Every time that counter will increase, and then every time it reaches a multiple of 10, it will spawn a pig above the block. That's it. That's all we want to do. So it's very basic, and obviously you can expand your logic from there, but for us that's just a very basic example that I can show you relatively easily. So I'm not going to fill out this onUse method right now, since we're actually going to create the BlockEntity class first, but do note that this is the method that is called when you go ahead and right click it with an empty hand. Now, to actually provide a block entity to our block, we need to go ahead and implement an interface. So we need to implement BlockEntity provider. Once we've done that, you'll see we get an error, and that's because we need to implement the methods. And the method that it wants is create block entity. Now, you will also see there is a get ticker method here, which we are going to be using in a following tutorial to make our block entity tickable. You can obviously experiment with that now if you want, but we're not going to be going through that for now. So we're just going to do with create block entity. Now, in here, we need to create a block entity that will be used. And for that, we're going to go ahead and create a new init class, which will register our block entity types. So let's have a block entity type init. And this is just going to pretty much be a normal registry class. So there isn't anything too special about this. So we're going to go with a public static final. This is going to be a block entity type, and this is generic. So the type that should be inside of this block entity type will be your block entity class. So we're going to have an example BE is what I'm going to call mine, and that will be my class. So BE, by the way, when I'm saying BE just means block entity. You'll see that referenced quite a lot throughout other mods and all that. BE is just block entity. And if you ever see TE, which you probably won't see anymore because it's kind of an outdated thing, TE is tile entity, and that's what people used to call block entities. So just in case you ever get confused with that, you shouldn't see TE anymore, but it does come up from time to time. So do note, tile entities, block entities, it's the same thing. I'll call it example underscore block entity, and I'll also rename this to be example block entity, just so that we can keep that a little bit clearer. Now for this, we are going to want our usual register method, and we're going to need to pass in the name. So example underscore block underscore entity. And you can also just call this example if you wanted, I guess. It doesn't really matter. I'm going to keep it example block entity just so that we know it's clear what it is. And for this, we're going to need to provide a block entity type, which we're going to use a builder for. So we're going to say block entity type dot builder dot create. We are first going to want a factory, which is effectively just going to be the constructor of our block entity class, which we'll create in a moment. So what we're going to want is we're going to want example block entity, and that will just be : new, which will be the constructor for that class. Then we need to provide a list of blocks that are going to be supported by this block entity. So all we're just going to put in here is block init dot example be block. And that's the only block that we have supported. If you had multiple blocks, you would just type those in here as well. So you might also want, for example, block entity. You might also, for example, want block init.example block as well. We only want our example BE block, so that's the only one we're going to put in here. And then after that, all you want to do is go ahead and build this builder. Next, let's go ahead and create this registry method, which is just going to be exactly the same as normal. So we're going to want a private static. This method will be generic, so we'll say t extends block entity, like that. And actually, let's not make this private, just in case we ever wanted to use it somewhere else. Then we can say this returns a block entity type of t, and we're going to call this register, of course, which will pass in a string name, and then it will also pass in a block entity type, which is the type, and that also needs to be generic of type t. And all we're going to do in here is return registry from net.minecraft.registry.register. We're going to pass in registries.blockEntityType. Then we're going to use our method from our main class, so tutorialmod.id, which will take in the name, and then finally that's going to take in the type. Then all we're going to want is our usual load method, so that this is loaded correctly inside of the main class constructor. So let's go ahead and put that in here, and that will be BlockEntityType init.load. Okay, so now let's go ahead and actually create our block entity class itself. So inside of the block package we just created, I'm going to create a new package, and I'm just going to call this entity. And then inside of here, I'm going to create the class for our example block entity. All this class needs to go ahead and do is extend block entity, and then we are going to add the constructor to match the super. Now for this constructor, we are going to remove this first parameter for the block entity type, and we're just going to directly pass that into the super here. So we'll pass that in like that. Then we can go ahead and import our class inside our block entity init, and we can now close this because that's done. And inside of our block, what we can do in our create block entity method is we can call BlockEntityType init dot example block entity dot instantiate, and we're going to pass in the pos and the state. And what that will effectively do is that will go ahead and call this constructor here, which is defined by the factory that we put in here. So this : new refers to this constructor, which is then what's called in here. Now you may be wondering, why don't we just do a new example block entity passing in the pos and the state? And you can do that if you do want to do that instead, but the instantiate here will directly call the factory, and the reason that it's better to do that is just for potential compatibility. There isn't really a well-defined reason. It doesn't really matter, but by using instantiate, if for some reason some mod wanted to inject into this instantiate method and do something, it means that you'd be compatible with that mod if they were to do that, and they wouldn't have to create a mix-in directly into your mod to go ahead and do whatever they wanted when it's instantiated. It's a niche case, and you don't have to do it if you don't really care. For the most part, it's not going to matter, because I highly doubt there's any mods even that actually mix into this method, but it's just, you should just do it because there's no reason not to. And to be honest, I think it's kind of more obvious as to what it does. So it references our block entity type, and then it instantiates the type using these pos and state, because you're never going to have a constructor with something other than a pos or state. And I mean, you could do, right, you could have another constructor. Say for example you had a battery, you could then also pass in maybe a battery type, which could be like an enum, right? So you could do something like that, and then as long as you called obviously this constructor right here, so you could call this with the pos and then the state, and then you might just set your battery type. So you might have something like this, for example, in which case you would probably want to go ahead inside of your block class, and you would actually just want to use that specific constructor. So you may have something like this. Alternatively, you can still use instantiate in that circumstance, so you can actually just do a example block entity be is equal that, and then you can just say, if you wanted to have it this way, you could say set battery type, but then obviously that means it wouldn't be able to be final, but you get the point. So it doesn't really matter whether you use instantiate or whether you just use the constructor. I personally just like to use instantiate because I don't see a reason not to. It exists, so I'm just going to use it. Okay, with that out of the way, and with all of this hopefully gone, so let's quickly remove that, we can now go ahead and actually do some functionality with our block entity here. So the first thing I'm going to go ahead and do is I'm actually going to store a quick counter inside of this block entity class. So all you do to store any data inside of a block entity is you just have it as a field. So we're going to have a private int, and I'm going to call this a counter. Nice and simple, right? So how do we access this counter? Well, we just create a public int get counter. And now that means we can go ahead and access this counter variable wherever we want. So wherever we have access to our block entity, we can now access this counter. So how do we access a block entity? Well, let's go ahead and have a look. So inside of our onUse method, we can actually go ahead and get our block entity. So the first thing we're going to actually go ahead and do is we're going to check that we're on the server side, because we're going to be spawning a pig in our specific circumstance. And to be able to do that, we need to be able to do that server side, not client side. So to check that we are server side, all we need to say is if world.isClient, and we're just going to add an exclamation mark which will negate that. So if we are not on the client side, that means we're on the server side, then we can go ahead and do what we want. Now, when do you need to be on the server side and when do you need to be on the client side? Well, that really depends. But for block entities, the majority of the time, you're going to want to be on the server side. And you'll see specifically even when we do our tutorial on ticking block entities, we're usually only going to even tick on the server side. We don't even want to have it tick on the client side. And that's because most functionality to a block entity will be on the server side, because you want it to persist between each player, so each player will have the same data inside of that block entity, whereas if it's only on the client side, then there's going to be different data per client, which would be a bit weird and a bit funky, and when it tries to save that data, it's not going to be able to save it correctly because it doesn't know what's client, what's meant to be the actual data. It doesn't know. So by having all of our logic on the server side, we know it's going to be fine. Now, there are certain circumstances where you may want to do client side things. For example, you may want to play a sound to a specific client, in which case you might have this be not server side, right? You might have this be client side. And if not, if you still need it to be server side, but you want to do something client side, then you have to send a packet to the specific client that you want to deal with, or all the clients if you need to do that. And we'll get onto packets in a somewhat soon tutorial. I don't know exactly when, but we will move on to those at some point. But the point is, for us, we're just going to be on the server side. Oh, and another circumstance, I should probably mention this one, is if we are having a screen for our block entity. So we're actually having a GUI. That's actually usually going to be server side, since we're going to have a menu, or in Fabric, that's actually called a screen handler, and that will be opened server side. So that's a little bit confusing, but we'll get onto those soon too, so don't worry about it too much. So if we are server side, what are we going to do? Well, we want to get our block entity. So let's go ahead and say BlockEntity is equal world.get BlockEntity, and we're going to pass in the pods. So this will go ahead and get whatever block entity is at the position we're clicking, which is hopefully going to be our block entity, but we have no guarantee that this is going to be our block entity, since get block entity just returns a block entity. It doesn't return the specific block entity that it is. So how do we get it as it is? Well, we could go ahead and just directly cast this, since there's a reasonably high chance that it is going to be our block entity. However, that's not a guarantee, and it could theoretically cause issues. So to be safe, what we always go ahead and do is we just have an instance of check, and we just say if block entity is instance of our example block entity. We can then call this something, so we can call this example BE, or example block entity. Then we can go ahead and do something with that example block entity. Now, I'm also just going to check that the player is not null. Now, I don't think the player can ever be null in here, but it's not annotated with at not null, so there's no guarantee there. So I'm just going to have that check anyway, since we are going to use the player inside of this if statement. So what we're going to want in here is if the player is sneaking, then we're just going to print the count that the block entity is currently at. If they're not sneaking, then we're just going to increment the counter. So how do we do that? Well, if the player is sneaking, then we can go ahead and send a message to the player. So we're just going to display this as a basic piece of text on the screen, nothing too special. So we're just going to say player.send message, we're going to pass this in as text. So we're going to say text.of, and then we're going to say example BlockEntity.getCounter, which is that method we just created. And this needs to be a string, so we're just going to do plus string there. And I'm going to pass in true to make this an overlay. So it will be just above the hotbar. If you pass in false here, then it will send it as a message in chat instead. Now, if the player is not sneaking, then we're going to want to go ahead and increment that counter. So the way we're going to do that is we're just going to create a method in here to increment it. So we're going to say public void increment counter. And all we're going to do in here for now is we're going to say this.counter plus plus, and then we are going to call mark dirty. And the reason we call mark dirty is so that we know that this data has changed and it now needs to be saved. However, this will not actually save it. So we're not actually saving this int here. The game does not know that this block entity is holding an int. And so we have to tell it to save and therefore read an integer. So how do we do that? Well, for that, we need to use something called NBT. And it's likely this will actually change very soon, and it won't use NBT, it will use components. There's no guarantee of that, but there's some likelihood that that will change in the future. But for now, we just have NBT. So for this, we need to override two methods. We need to override write NBT and read NBT. So inside of write NBT, we can go ahead and write whatever data we want to save to the NBT. So any data you want to save, and it's ideal that you don't write unnecessary data. You try and write as least as you can so that you're not saving a bunch of data into the world file. So all we're going to save is our counter, but it's generally recommended, or at least from what I've seen, that you put this inside of a special component that is specifically for your mod ID. So specifically, when we have something just called a counter, it's recommended that you save it somewhere that is unique. Because if we just had an int counter that was saved inside of there, what if another mod came along and that mod wanted to save an integer inside of our block entity, right? Maybe maybe it needs to save how many times you've done something with your block entity, and it just saves that as a name called counter. Ideally it wouldn't do that, right? Because that's bad and it could cause problems on our end, so you wouldn't really want to be doing that from their perspective anyways. But you might just want to be safe in our circumstance, and we just want to prevent that from happening. So the way I've seen people do that, and kind of the way I've been doing that personally, is by having a mod ID data. So I call this mod ID data. I set this to a new MBT compound, and then what I do is I write all my data to this mod ID data. So I'll say mod ID data dot put int, since we're going to be saving an int. If you're not saving an int, then you can use one of these other methods, of course, whichever one best represents what you want. So we're going to put int, I'm just going to say counter, and then I'm going to pass in this dot counter, and then all I do is I say mbt dot put, I'm going to put tutorial mod id, and then I'm going to put mod id data. So that will just save it kind of in a mod id, which is our mod id, and then it will name it counter inside of that. As I say, you don't really need to do this. It's a bit unnecessary. Some people will tell you it's useless. Somewhat it is useless. Somewhat it theoretically could be useful. It's up to you whether you decide to do this. If you think it's too complicated, don't worry about it. You can just do mbt.putInt counter this.counter, and obviously that is significantly simpler to both read, understand, and everything. Actually, for the sake of this tutorial, I will just do this just to keep it simple, but if you want to do it my way, then you can do that if you want. Inside of read MBT, you guessed it, it's going to be just as simple as you expect. Now, I'll quickly show you how to read it using my way, and then I will show you afterwards how you read it using this way. So what we're going to do is we're going to first check for that compound I created. So we're just going to have if mbt.contains. We're going to check if it contains tutorialmod.modid, and we're going to check that it has it with the mbt element of compound type, since this would be saved as a compound. If it does, then all we do is get the mod ID data, which is going to be equal to mbt.getCompound, and that's going to pass in tutorialmod.modid, and then we can just set this.counter to modid data.getInt, and we can just pass in the counter. Now you also probably should check if it has the int before doing this, so you could also say modid data.has or modid data.contains. You can say counter mbt element.int. If it does, then you can use modid data.getInt of counter or 0. You could do something like that, of course. And that's actually what we're going to do if we're not saving it like that. So we can actually just use mbt.contains counter, mbt.getInt counter, or 0. Okay, so that's how you go ahead and save that in both different ways, using my way or using the traditional way of saving it. Whichever one you choose to do, it doesn't really matter as long as you're saving and reading in the exact same way. Okay, so now that we have done that, we can go ahead and call our increment counter inside of our onUse method. So all we're going to do is we're going to say example BlockEntity.increment counter. So you'll see that we still have an error in here, and that is because we need to return an action result. So if you come into action result here, you'll see there are a bunch of different results. So you'll see there is success, which, as it says here, it indicates that the action was performed, and therefore the hand will swing to indicate that it was a success. You also have consume, which indicates that the action was performed, but there will be no swing hand animation to accompany that. Then you have consume partial, which indicates the action was performed, no animation should accompany it, and no statistic will be increased either. Then you have pass, which indicates the action was performed, but any other actions can also be performed. So for example, you may have it allowed to pass when you're right clicking with, I don't know, an axe, for example, but then the axe may also want to do something afterwards, and so you would do a pass, which allows another action to be performed by another source. And finally, you have the fail, which means the action was not performed and any other further kind of actions will be prevented from performing. So these are the different options of which you can choose to use. Now, funnily enough, we're actually not going to use any of those. We're actually going to use return action result .success, and we're going to pass in world.isClient. So to the client will get success because we're passing in world.isClient. So that will swing the hand on the client, but then on the server side, it will just use consume because we don't need to swing the hand on the server side since only the client is going to be swinging their hand. And so the server side will get the consume, whereas the client side will get success. So that's how we go ahead and do that in there. Okay, so we're pretty much complete, but the final thing we want to do is we want to spawn pigs, right? We want to spawn pigs every 10 increments. So how do we do that? Well, luckily, this is super duper simple. So all we're just going to say is if this.counter modulus 10 is equals 0, right? So basically, if the number is divisible by 10, so there's no remainder, then we are going to say entity type .pig.spawn, and you'll see this needs a server world. Now for now we're just going to use this .world, but that won't work and you'll see why in a second. And then we're going to pass in the position, so we can just use this .pos. I'm actually going to say .up, so it's above the block and it doesn't spawn inside of the block. And then we're also going to pass in the spawn reason, which for us is just going to be, this is a triggered spawn, it's triggered by something, so we just give it triggered. And as I said, you'll see that the world does not work. That's because it needs to be a server world, which I mentioned earlier, and that's why we have this check here. And we could just safely cast this because we know that in this circumstance, it's always going to be server side. However, maybe this was called from another source that wasn't necessarily doing this if check. And so in that case, we can just say, and this.world is instance of a server world. If it is, we'll just call that the S world for simplicity's sake, and then we can just pass in the S world as this first parameter. Now that is pretty much it. So we can now go ahead and close these. You can now run your data gen if you haven't already done that, and we can run the client, and hopefully we should have our block entity in the world and it should function as we want it to do. So if we place down our block here and we go ahead and first of all shift right click it, you'll see it says 0. So if we right click it again and then we shift right click, you'll see it now says 1 here. And if we right click a few more times, we're now at 6, 7, 8, and now at 10, it goes ahead and spawns a pig. Obviously, if we just spam it, you see it will start spawning a bunch of pigs. And obviously, we could go ahead and send that message every single time. So inside of our block class real quick, we could go ahead and actually send this message even if we're incrementing. So what we could say is we could do something like this. And we could just say instead, if the player is not sneaking, then we're going to increment the counter, and then what we can go ahead and do is send that message regardless. And what that will go ahead and do is if we restart the game, we should now be able to see that it will send that message whether we're sneaking or not, but only if we're sneaking will it actually increment that counter. So we can try that real quick and see if that works. So if we now right click it, you can see that it increments either way. Oh, because we actually had it the wrong way around. So I actually wanted only if it's sneaking, it will increment it. Okay, but that's fine. So you get the point. So you see how you could easily change that. So if we're only sneaking, now it's not going to increment it. But if we're not, then it's just going to increment it every single time like that. Actually, maybe that's better than just having it only do it on shift. But yeah, you can see how that works. And obviously maybe you want to do something when it reaches 100, right? Then you would come into increment counter here. You could maybe say if this dot counter percentage 100 is equal 0, and we'll once again do that world check. So we could actually do that world check here, and we could say if not this, right, then you could return, and then you can get rid of that there. And you could say if it's 100, then you could do entity type dot lightning bolt dot spawn s world this dot pos dot up and spawn reason dot triggered. You could do something like that, and what that would do is when we reach 200 or a multiple of 100, you see it now spawns a lightning bolt, but the rest of the time it will still just go ahead and spawn pigs. And obviously if we leave the world and join back, we should be able to see that it's saved the amount that we were at. So if we join back, you see it's now still at 222, and we'll just increment it a little bit more, so we'll get to like 240, save and join back. We should be able to see it's now at 241 when we right click it. So you see that works perfectly fine. And that basically is a block entity. So obviously in the future tutorials, we'll make more complex block entities. We'll do, ticking, we'll do GUIs, we'll do custom recipes, we'll eventually move on to block entity renderers as well, and hopefully at some point we'll do multi-blocks, because that will be really fun if we can do that, and I really hope to do that. We'll also do sort of energy, we'll do storing items, we'll do storing fluids, all these kind of things. You can go ahead and look at some of my past tutorials in Forge to get an idea of the kind of things I'm going to be covering with block entities. I do hope to be doing a lot with them. And I will note, I'm not just going to be doing block entities for the next, 50 tutorials or whatever. I'm going to make some other stuff in there as well. So I hope my plan right now is to have one block entity tutorial a week and one non-block entity tutorial a week, because I would love to get an entity tutorial out, because once I've done entities, then I can do a biome tutorial as well. And obviously once I've done biomes, then I can do a dimension tutorial. So that'll be a little bit exciting. We can also do, for example, projectiles at some point, and we can also do other things like that. There's a bunch of things that you guys have requested, and I have seen your requests even if I haven't replied to them. There's a high likelihood that if I haven't replied, then I probably am actually going to do it, which is why I haven't bothered replying. But I just don't have a time scale for a lot of these things, so I'm not willing to really give one because I don't know when things are going to happen. But yeah, that is it for this tutorial. So obviously I hope you found it useful. If you did, please do be sure to give it a like and a subscribe as well. If you have any problems, obviously you can join my Discord server, which is linked in the description below, and if you ask in the modding channel, then you can possibly get some support in there. And yeah, I will see you in the next tutorial. Goodbye.